months, customer issues, workarounds, um, gotchas, things to look out for, all within the realm of software distribution. So hopefully you'll find them useful. We delivered this a few days ago at the MMS Jazz, and it seemed to be quite well received. So we're going to do it again. We've tweaked it a little bit, but not too demo heavy. The slides, which will be available, should be treated as a reference to take away, because most of the information that you need is in there. There will be a little bit of a demo if all goes well, but mostly it's all about how you can avoid some of the really painful issues that our customers have come across around software distribution.
So it's a bit more like a good night story rather than a demo heavy presentation. So most of the key information that we will be talking about will actually be in the words that we say, not the presentation itself. Because we will present all of the different issues that people have had over the last couple of years that we worked with large organization, and they've been doing a lot of software and OS deployment.
So yeah, a lot of stuff. Obviously, we've changed the names to protect the innocent and the guilty. But we are going to start out with a little bit of networking theory, because a lot of the issues that we come across boil down to issues in or around the network. And so there's a few key things that we thought we would share around the network and how it's used and how it's overused and how human nature comes to affect these things.
So basically, if you're thinking that network traffic or regular traffic can be built away, if you study the typical examples, you can see that the common misconception is if you just add more lanes, traffic will, basically slow traffic will go away and all the cars can go faster. It's quite easy to think that when you're sitting in your car and everything's standing still. If you just had one more lane, things would actually go faster. But looking at history, we can see that maybe this doesn't actually solve the problem. And this isn't actually the first thing. It wasn't actually traffic that was the first thing that people started seeing the same theory. So it actually took a British guy to build some stuff around that.
Yeah, this is a very, very true quote. The demand upon a resource tends to expand to match the supply of the resource if the price is zero. So this was a guy, Mr. Parkinson, who worked within the government, and he basically, because he worked for the government, had lots of spare time on his hands because he wasn't doing much work, but came up with the theory of Parkinson's law, which is pretty much the same analogy as the networking, the traffic, the cars, in that the bottom line of this Parkinson's law is that whatever the medium is, we will always fill it up, right? So at home, if you add more storage, you add more desk drawers. If you add a basement to your house, you add a garage, you will fill it up with stuff. Budgets, you get a bigger budget, you use it all up. Hard drives, etc., etc. You get the picture. So really, in terms of networks, it's exactly the same. The bigger the network, I mean, a lot of our customers say, "Oh, yeah, it's a bit slow today, but we've got a project to fix that." It's always kind of ongoing.
Yeah, I think every single customer that we've talked to the last few years, every single one of them do have a network upgrade project that's, I mean, some of them have been running for many, many years,
Many,
but
many
there,
years.
but there's never any problem to change the current behavior because there's always going to be, a next version to fix it. But as we worked so long with within this actual space, we can see that yes, you might upgrade, i.e., build more lanes, but the traffic will only fill those lanes very quickly. So the more traffic, the more free, the more free networking that is available, the more people are going to fill it.
Yeah. So the takeaway from this really is that even if you're having issues and your network team says it's okay because we've got a project to fix this, we're going to put internet breakout everywhere, we're going to increase the bandwidth. Don't take that away as meaning that everything's going to be fixed. It doesn't necessarily follow.
No, and it's interesting because we had one customer that we talked to a couple of weeks ago, and they had big issues around network slowness, and everybody jumped on a call, conference call, because the media fills the medium, works within the enterprise, so everybody gets to get on every single conference call, and the issues being discussed. And in this case, it was the users, they were perceiving slowness on the network. They could not use their actual teller application as it was intended. And the issue, when it boiled down to it, was not any latency, it wasn't any bandwidth on the network. It was actually the CPU. The machines were so busy doing patching, and Microsoft has done a great work to reduce the size of the actual patches with the new update mechanisms that we have in Windows 10. But the reduced size comes at a cost of reduced CPU, because the CPU has to do a lot more work to figure out the differences that it needs to apply. So in this case, these were teller machines, and they were bought at the absolute lowest possible spec. So they were actually Pentium machines. So they were not Intel cores or any more high spec CPUs. And when the patches were applying, the CPU took so much of the the patches took so much of the CPU work. So the machines were unable to do any sort of actual proper work. So the machines were unusable. And of course, they said that the network was slow because the application that they were trying to use did not work.
So if you get a call saying, hey, the network's really slow, don't necessarily look at the network in isolation is the key. I mean, perceived slowness is not necessarily the actual the end of the root cause. So it may be that the network looks like it's being slow, but it might be any number of things. And we're going to give you some real world examples to follow on from this. And it's kind of a vein that runs through a lot of these examples, is that in the job of an admin, what you have to do is kind of think outside the box a lot of the time. Sometimes we have issues that look so obvious as to what the cause is that we go down a rabbit hole that we later come out of, and it turns out we went down completely the wrong path. So we're going to give you a few examples of how Parkinson's law manifests itself in the enterprise, how you can get around it, and what you can do about it. So I like this slide. Config Manager has great powers. With these great powers comes great responsibilities. Number one, you would be amazed actually as to how many customers we work with that do not have a test environment of any shape or form, and it's really quite inexcusable.
I thought prod was test, and test is prod.
Well, that's the problem. So do a lot of people.
Yeah.
It's so simple. I mean, if you go to Mr. Arvid Mark's website, Deployment Research, he has a really great hydration kit. And and you can build something pretty good, you know, within the space of an hour or two of spare time, with hardware that's not going to break the bank. So it's not only going to possibly, you know, get you some brownie points at work because you're not going to break the production network. It's also quite a good environment to learn in, because I think human nature kind of dictates that if we have to do everything in production, we get a bit brave. If we haven't broken anything for a couple of months, we get a bit cocky and we get a bit brave, and so we tend to just get a bit gung ho, and eventually something's going to break. You know, you can't test in production and expect it to never break anything. So get a test environment. It's so simple. Um, Automate it. You know, put a bit of effort in and make sure that you can flatten it and rebuild it at the drop of a hat. Make sure you've got at least an environment that matches roughly what your production environment is. So make sure it's the same kind of config manager version, etc., so that you can replicate any issues that you see in production, for instance. But the basic rule is, if you don't have a test environment, get one. I'm amazed that we actually still have to have this slide, but we see this day in, day out. And it's such a simple thing that can fix a lot of, or it can head off a lot of potential issues. So what's this one about, Andreas? Who said this?
I'm fiddling. It was actually an SI that works with all of our stuff. And it's funny because we have customers of ours that have other customers that they serve our software to. So typically they don't come to us for questions, they go to their actual SI. And this is quotes that I had from Teams from a consultant, and basically he was complaining that everything, you know, this customer, everything was slow, and he would basically he decided to set time aside and to show the customer how to find the answer to some of these questions, and at the same time solve them himself. And in this actual example, they had a build time that was around 4 hours per workstation, using user over the wire, no remote servers. So it was a wide area network. All the content had to come down. They were still using peer-to-peer, but obviously something was not right. So they, by doing a bit of research, they actually figured out what was going wrong. They, one, read the manual. They did, B, actually Google some of this, the actual output of some of the logs, and they were Googling some of the scenarios of what they were seeing. So that, by doing that, and this was about a half-day exercise for them, they went from a build time from about 4 hours down to 50 minutes. And this, they had a pretty heavy desktop or base image and lots of apps that came down. So 50 minutes was a pretty good good actual time to do. But it displays what actually taking the time to figuring out what you're trying to do makes complete sense.
Absolutely. So the next one is one of my favorites. And this actually should be pretty much gospel for everybody. Don't distribute 8,000 files in a package. Why should we not do that, Andreas? Why is it a bad thing?
So for each file that you have, when bits, which is typically what we're using to do downloads, each file actually creates a new connection because it needs to reconnect to actually download the new file. So there's a new HTTP call for each file instead of being just a range request, which is smaller. And especially if an HTTPS, then it needs to do a whole new renegotiation.
Come on, you can do it.
Renegotiation of the whole TLS infrastructure. So, and that is very heavy on the CPU side of the server. So the more of the HTTPS request that a server gets, the more CPU time it needs to spend towards that. So if you got multiple clients, multiple downloading packages with a large number of files, you will see that the CPU on those servers will skyrocket. So it's both bad for the local performance, i.e. getting the files down, but it's also bad for your servers. So what we're trying to do here is to get as few files as possible to download, because that will help the server. But most important, it's absolutely key for the peer-to-peer performance. Multiple files will be an absolute disaster for the branch cache performance. Some of that is due to not having any flashcard creation, i.e., which is a built-in mechanism in branch cache to find out where other clients are downloading the same content, i.e., not overloading your WAN. And also, if you have large files, it's very likely that they will be small, which means that branch cache will not kick in. Branch cache only typically kicks in by the default settings for files that are larger than 64K. But I think the biggest issue is the speed that it takes to transfer. Transferring packages with large number of files with branch cache is very slow. The other big problem is that it creates an actual server database bloat, because each segment will then, if you have large number of files, you'll have large number of segments, which creates an enormous database, which could lead to database corruption and other issues. So I think the worst thing we've seen over the last few years was someone was complaining that download took a long time, especially using branch cache, and he was blaming branch cache for the whole download being slow. And we asked him, how many files do you have? And he said, well, it's quite a lot. And we said, well, what's a lot? And he said, well, it's about 1.5 million files.
Yeah, and people expect them to just download magically with no impact. The thing is, if you have one massive file of so let's say if you have a huge file of a gigabyte or whatever, and if you have 1,000 files that add up to a gigabyte, the single gigabyte file is going to win every time, for the reasons that we've just discussed. But even if you're not using peer-to-peer, even if you're not using branch cache, it's just good practice. It's not going to download quickly if you have a package with thousands of files. And we're definitely pointing the finger here at driver packages, because they're one of the big culprits. It's not uncommon to have over 1,000 files in a driver package by any means. So that can slow down your OSD process, for instance, quite severely. So this should be something, it's easy to tick off your list. It's easy to kind of avoid this. We did have a demo at this point, but it wasn't very exciting. So I decided to replace that just with a slide so that you can take this away. But really, the way to get around this is to use zip or some other method. When we say zip, however, don't go all in and try and use the most aggressive kind of zip that there is. Like, don't use 7-zip or something like that, because that uses quite an aggressive and efficient algorithm. Just use the bog standard built-in Windows zip, because that's quite easygoing. Just create a single file, and you can deal with that within the package itself, instead of just running setup.exe, whatever. Have a PowerShell wrapper that will unzip things and then call setup.exe. I think the PowerShell deployment toolkit has that in there. The PowerShell app deployment toolkit already has the facility to do this. So if you're using that, use that function. iExpress, which is like a packaging tool, is still built into Windows. I checked that. It's still in 1903. If you go to Start Run iExpress, then up it pops. And so you can actually do a quick and dirty packaging exercise with that. Another thing that another approach that some of our customers use is to actually use a VHD. So you create a VHD, mount that, put the files in there, and then at the other end you can mount that drive and run setup from there. That's quite an efficient way of doing things. But however you do this, then do it basically. Don't just distribute files that have thousands of files in a package or application, because they all have to come over the wire, and it's just not very efficient.
And I think we'll get into this, but there's also an upper limit to where a single enormous file might not be what you want to do either, but we'll get to that.
Yes.
So, which is basically the next thing that we're diving into. But we had a customer who contacted us and basically said that their patch status was really bad. They weren't getting the patches out, and of course it must be a network issue since clients are not getting their content. So, being a Parkinson's law thing, everybody has to join the conference call. The more the merrier. And what it boiled down to was basically that this was a brand new config manager installation. It was implemented sometime around May, July timeframe. So it's, pretty new to that state. And what it was that the customers were adding all the patches for their desktop estates into the same package every single month. The thing is, they didn't remove the old ones. So packages just grew and grew and grew and grew. And I think there was a few different packages floating around, but they were in the range between 65 and 100 gigabyte. And the problem was, as their main site servers trying to get this to the DPs. If we slide over to the next slide, Phil. With a large bang on the keyboard.
Yeah.
The problem was,
sorry, you woke me up there.
Basically, the configuration manager backup ran daily. And when that runs daily, it means it stops the disk manager threads. It stops all threads and all services. So that problem, when a disk manager thread is stopped, it's actually stopping the distribution that it's doing, and it has to restart from the beginning. So these enormous packages they restarted, consuming large level of bandwidth each day to try to get these 65 to 100 gig packages over to these DPs. And maybe when it was like 97% there, or even 99% there, it was time for backup, and everything shut down and all the threads stopped. And when they started up, they would have to start from 0% again. So there is a fix for this, which is to use SQL backup instead. Steve Thompson, who's an MVP, has a great blog on what to set up. And as you can see from the URL, this has been around for a long period of time, which is something that you should definitely think of putting in. Not so much for the actual disk manager threads, but for other reasons as well.
Yeah, but also, keep check of your ADRs, if your package sizes, because there's no point distributing stuff that's kind of 6 months old, right? So keep it lean, keep it mean.
Yeah, and as John Arvidmark said, which is a bit of a quote now internally, 33 gig packages is way better than 100 gig package.
Every time, yes. So yes.
This is actually from the same customer. They're getting a bit of a brainwash here, but we had the same customer where that wasn't doing any patching. They also, their operations teams basically realized that this branch cache service was enabled all of a sudden. and it wasn't enabled when the service was built. So therefore, it's an anomaly, and it should be disabled or removed. And I guess that's the right thing to do for an operation team. It's just hard to troubleshoot when it happens 3 months after the server was built. I don't know if they had a new intern that started and he was following the checklist to see which services. And even in this case, in some servers, it was the service was just stopped. So it was installed but not removed. And on other servers, it was actually removed completely. So it was really hard to troubleshoot across the distribution points what was going on.
Yeah, and we have a little a demo in a little while that will help you check these things. But this example is kind of about communication in a way, because it's about the the config manager admins talking to the server team, because when we configure, for example, branch cache or Leadbat or any of these Windows components from within the config manager UI, I mean, we configure stuff within config manager itself, but we also have the capability to configure components that belong to Windows, to the server OS itself. So if you're going to do that, let the ops team know, let the server team know, hey, look, we are enabling branch cache on these distribution point servers. And it's a Windows feature, okay? So add it to your checklists, because otherwise this is going to happen. Some bright spark that wants to make a name for himself is going to come along and go, oh, this is not on the list. This is not, a non-standard thing that's been installed, so they're at least going to stop it. So head that off. Make sure that you've got good communications with your ops teams.
Yeah. And the next thing was we had a customer where, and this took forever. It was one of the most major cases that we worked on over the last year, where all of their bits downloads, regardless of what it was, policy or content, etc., the bits jobs used error out and go into suspend mode or transient error. And Microsoft was on site for weeks. Nobody could figure it out. But the issue was someone had done some configuration change to change the account to which the branch cache service runs to be local system instead of network system. And it was such a fundamental thing that nobody expected it to be present. So everybody was running around as headless chickens for weeks. I mean, I'm not talking small teams, I'm talking big teams. Microsoft was involved. The next step for Microsoft was to send an actual debugger on site to figure out what was going on. But it was figured out. And it was such a trivial change. So don't expect that it's going to be a complicated fix just because it's a complicated error.
Yeah, but if things suddenly stop working, then of course something has always changed, and it's about working methodically to figure out what that is. And the fix for this was so trivial and so kind of in your face, but we'd been running around for weeks, as Andreas says, and looking at debuggers and all the rest of it. Sometimes the issue can be staring you right in the face, so always check the basics from day one. This is a pretty useful one as well. If you have a site, so a little bit of history. These days, if you're using branch cache, then it's automatically enabled. If you create a deployment, it's automatically enabled for branch cache, providing you've got the client settings in place and your distribution points enabled. That wasn't always the case. There used to be, back in the good old days, a checkbox on packages and on applications and software updates, deployments that you had to check for each deployment. So branch cache was enabled on a per deployment basis. But now that it's auto-enabled, that's all well and good. But if you're running a site that's been migrated, that was built before that came into play, you may still have some deployments that are not branch cache enabled. So, or if you've migrated packages into a new hierarchy, as we saw at this one customer, they had 400 packages that were migrated over from an older config manager hierarchy that weren't branch cache enabled, and they bring those settings with them. So what happens then is that people turn on branch cache and then they get really bad statistics because these deployments are not enabled. So what we have to do is retrospectively go and check that everything is enabled for branch cache. And so we have some scripts on the website that you can run against your site server, which will iterate through all of the packages and applications and software updates, and it will tell you if they're branch cache enabled or not. So if you've got an old site that's been migrated up to the latest version, and you want to use branch cache, then run this script, and all will be good in the world. Pretty simple.
So, and that's, I mean, pretty simple, pretty much explains this whole scenario as well. Disks did just fill up, right? So hands down, we've been dealing with a lot of customers where we find their distribution points have completely filled up their disk space. And it's a bit like, really, do we have to go through this in 2019? Just check your disk space, know which drive that has the content library on. If it's on the C drive and, for whatever reason, the other drives are not available, yes, it will fill the drive and it will starve the OS and the server will not be happy. So I think we can move on from there. So do check your drives, guys.
Yeah. But I'm going to try and hopefully without killing the whole presentation. There we go. We have some scripts that were written by Mr. Arvid Mark that should be on this machine here.
It's a bit small. Can we expand and zoom?
Yeah, let me see.
Maybe do control. Yeah, that's beautiful.
Okay, no, wait, I need to do control 4. There we go. So this is fairly simple script, but this can save you a lot of time. So what this is going to do is it copies a script to each distribution point, and this is kind of a distribution point health script written by Mr. Arvid Mark and Jordan Venzing and some other clever people. And so it copies a script to each distribution point, runs the script, and saves the output locally. And then at the end, it combines. So it basically saves a CSV for each distribution point. And then at the end, it combines all of those CSVs into a single file. So what you end up with is a nicely formatted spreadsheet of the current status of all of your distribution points. What does it check? It checks things like disk space. We mentioned disk space. Checks the free disk space drive letters, content library drive letter, the branch cache service status. Is it enabled? Is it started? Where are the caches located? So another common issue is that the branch cache, publication cache, which is where the hashes are stored, without going into too much detail, defaults to the C drive. And if you've got a large content library, that is going to build up quite quickly. So the publication cache can grow quite quickly. So it's good practice to move that off of the C drive. So we check all of these things. Do all of the grunt work that you would do manually, report that into a CSV, and then at the end we combine them all. So if I run this, I've only got one distribution point here, but what we should get is a nice little report that's not very interesting because it's only got one entry, but we'll make this available in some way. We'll either stick it on our GitHub or on the website. So all you need to run this is a folder structure like this. So you have one folder called DPs into which every DP drops a file. You have your scripts folder, you have a results folder. What you get is a DP health summary, which you can then load up in Excel, and you can instantly see lots of lovely information about your distribution points. So that's just a little useful script that we're going to make available to you that you can take away and use in your own hierarchies, because if you're managing more than a few distribution points, and I know that a lot of you are, then this is a really simple way to run a health check on a daily basis. Like most of our customers, we set this up as a scheduled task. It runs every day, and so all you do is you come up in the morning and check the folder and look at the summary and just make sure that everything is still humming away.
Perfect.
Okay, so
yeah, so we got 7 minutes to do a few slides here.
This one, we don't have too many slides left.
This one we can basically say none. Well, let's put it this way: every single one of our customers say they have 100% control of the boundaries. And we can say that 100% of our customers have no control of the boundaries. Every single one of them are basically sending data across their WAN in a way that they did not intend it to do. Obviously, we work with large organizations, but it shows you the complexity of behind. There might be network changes or IP ranges changing or 80 sites changing in a way that they are not actually aware of. And within the toolset itself, there's no way good to find out.
No, but the way that this might manifest itself, for instance, is if you're getting really slow performance. So if you're getting phone calls from a location saying, oh, the network is really slow, it could be that your clients at that location are pulling from completely the wrong place. So it's a good place to look, check your boundaries, check your distribution point affinities, are they all configured correctly? Just again, going back to right at the beginning where we said, perceived network slowness is not always down to the network. Okay, it could be down to the configuration of your boundaries. And this is really popular. Yeah, this one.
Yeah, let's redirect to Microsoft, which is a great thing to do, but you should know what to redirect for, because just because the internet has a large amount of bandwidth doesn't mean that you have a large amount of bandwidth to the internet. So we had people thinking they were using or going to use the internet breakouts in the right way. They said, yeah, if the content is not available on the distribution point, then we'll get it from Microsoft, which is great for customers that maybe had DPs that were small, they couldn't get the content out there. But in this case, we had a large customer. They enabled this, and they forgot to send the updates to any distribution point. That meant that every single customer went to the internet at the time of deployment without peer-to-peer to get the content. And if you're dependent on peer-to-peer to save you, that means that you will not get that, and everything will go over the WAN and over the internet and take down the internet. So please be sure when you check this, make sure you understand what you're doing. There are some stuff that are good, like definition updates. They can be pulled from Microsoft. They're pretty small. They're large in size, so they'll save size from your distribution points, and the downloads themselves are pretty small. And what about VPNs, Phil?
Yeah, I have no idea what this means.
No? So do you remember we had a customer where they said all of their VPN traffic had local internet breakout, and
Yes.
they distributed with these Windows settings, basically the same as the first one, but they didn't want to put anything on their distribution points because they thought they knew everything. But the problem was that there was a configuration issue on the VPN. So basically, Windows Update traffic was not going through the internet or the local breakout. It went over the actual VPN. So they took down every single VPN connection instead.
Yes. So the moral of the story is there are many more options these days to as to where you get your content from, right? So it used to be that we always got content from distribution points, and that is changing. And not only if you might be using co-management, so you might be getting content from Intune, but also within Config Manager itself, there is now the option to get more content directly from the Microsoft CDN. So just be aware of that and be careful how you configure that because of the scenarios that we've just described. Okay? It's not kind of a silver bullet to fix everything. If you've got bandwidth issues, just trying to get more content directly from Microsoft is not going to be kind of the magic fix that you expect.
No, and the next one, the last, I think this might be, or no, we got one more after this, but this was something that is actually a bug in the Config Manager code where when content is persisted, you set to the deployment to persist the content inside the cache. When a task sequence is started, if content is persisted, it does not check the version of that content, which means that which hit this customer as well. So if they make a really required change to a driver package in order to make their 1809 to 1903 upgrade work in there, but they've previously distributed content and told it to persist, it will pull the old version regardless, which means that if you're thinking you're using the new driver package version, you're not, you're using the old one. And this is a bug and it's supposed to be fixed, but it's something to be very aware of because it could potentially damage a lot of your actual feature upgrades. So keep track of what content you do persist, i.e. if you're branch caching, our view is that you shouldn't persist anything because branch cache will persist that for you. But if you have persisted content, make sure that you know what you're doing around this.
Yeah, so especially watch out if you're using peer cache, for instance, because this can catch you out. Okay, Leadbat. Who's using Leadbat? Everybody, hopefully. This is really about kind of about how we as admins interact with the network team. So the great thing about Leadbat is that it enables you to use 100% of the network really efficiently. So there's no traffic on the network, we'll use 100%. Why wouldn't you? It's there, so you don't want to waste it, right? So we can be transferring content. And if other content comes along, other non-Leadbat traffic comes along, then Leadbat's going to back off and do its job. The issue with that is where the network team has alerts that trigger, for instance, when the network gets to a point where it's 60 or 80% busy. So this happens in a lot of cases. Even though Leadbat's using the network really efficiently, there are alerts. So if it starts to use 80% of the network, they get a ping. One of their dashboards goes red, and they start to get a bit nervous, and then it goes up a little bit more, 90%. Then it starts to flash, and then they start to call you up. So you as an admin start to get calls from the networking team, like, what's going on? Why are you using 90% of the network? In most cases, there will be no user complaints, as the slide says, because we're not actually impacting the network. What we're doing is we are actually potentially impacting the network team's bonus, because what transpired was that in this particular instance, the network team's bonus was triggered by not having any issues, not having any of these red light incidents. So they set really low thresholds, like we'll have an amber light at 60%, we'll have a red light at 80%, and anything at 90% means we'll just go to total war. So really, if you're going to implement LEDBAT, make sure that your network team is completely okay with that. Talk to the network team and explain how it works. And if you're not sure how it works, then there's lots of good content out there, articles to explain that. But in this case, really, it was all kind of a storm in a teacup. LEDBAT was doing its thing. It was just that the network team was being super cautious because it was nearly bonus day.
Yeah, so in this case, the scenario was basically, or what Phil just went through, there was no user complaints. It was just network team complaints. A very different way was this customer who thought they were using LEDBAT, so they couldn't actually take down their wide area network. But the network infrastructure was that they had a few hundred locations, had a big main campus, which had the main data center. That connection was a 5 gigabits per second switch trunk. So, i.e., it was a big switch. A lot of, probably proportion of a 10 gig network connection went into it. It was pretty busy on average. Maybe at peak times it was about 4 gigabit used, so about 80% usage. And someone had the software distribution blues, and basically this was a case of a peer cache organization, and they thought they had the install WIM sent to their super pairs. They didn't. So what they did was they sent it to everybody. And of course, since their peer cache sources didn't have it, it all timed out and all of the machines went over the WAN. The problem was that it wasn't actually the buffers in each location because they were saved. It was the big switch that went bananas, because as the big switch, it's a big switch, it has a big buffer, but it has so many other connections going into it that it fills this buffer very fast. So as this buffer fills, when it's 100% filled, it can no longer buffer. And if it can't buffer, there's only one thing to do, which is basically drop the package. So the big switch started dropping packages. But as the line speed is so high, it means that it eats the buffer within a few milliseconds. So basically what we have happening is complete buffer bloat, i.e. it's full, drop packages, completely empty, and just fill up. So latency was never really driven up in this case because the overall latency was still pretty good. It was just a large number of package being dropped. So as latency was not increased, and LEDBAT really kicks in when it sees an increased level of latency. What you saw happening was all of these TCP connections, they were dropping a lot of packages, and as TCP sees a lot of packages being dropped, of course it has to resend them, which actually creates an actual additional flood of resend of packages. So depending on how bad things fail, you can actually create much more traffic by dropping packages, because then now everything has to be resent again. So this was actually what happened. And the actual main telephone switchboard went to the same switch, and basically they were starting dropping calls, so you couldn't actually call through. You can reach this company, nothing was getting through, and they thought that they would be saved by a technology that they didn't really understand. So it makes sense to understand the technologies that you're implementing, understand how they will react in certain scenarios, and back again, if you had a test environment, you would have been able to test this scenario. Of course, it's hard to recreate 5 gigabit of actual data going the wire, but there are things that you can do in order to help yourself around some of these things. So be aware that just because you're overwhelming the WAN, you need to know where you're overwhelming it. Is it in the main data center side of things, or is it on the actual i.e. the link from the location over to the main switches? Because depending on where it is, if each of these locations were filling their own buffers, that would drive latency, because all of the packages will then be spread among a large number of buffers. And as these buffers are being filled, that drives a very high latency, and lead bad will kick in. So there's an element here which is basically understand the technology that you're implementing. Just don't read that, well, this will save your WAN, check the box and think that it's going to be okay, because it might not. Things are always more complicated.
It might seem obvious, but it is really. Understand what you're deploying out there. So finally, we're like a minute or two over, but we're just going to quickly talk about Wi-Fi networks, because this is something that's come up a lot in the last kind of 12 months, 2 years. Wi-Fi networks can cause any number of issues, but these are probably the most common ones. All traffic can be routed via one single point. Well, that's reasonably common. It's called central switching. It's a Cisco thing. And it's basically where your switches reside in the data center, and all of your Wi-Fi traffic from a remote subnet goes via that switch in the data center, which is, it's okay if you've got fast links back to the data center. It's okay until you want to do any kind of peer-to-peer stuff at all, because obviously if you've got machine A on the same subnet as machine B and you want to transfer some content between them, then it's all got to go via the access point and back via the data center. So it's hugely inefficient. And in that scenario, there is really no point whatsoever using peer-to-peer technology. This has come up a couple of times. Customers of ours where they've tried to use branch cache in this instance, but it would have been the same with any peer-to-peer technology, and they got really bad results, quite understandably. And they just didn't understand how their network works. It took several quite long discussions with the network team to actually get to the bottom of what was happening here. And it was down to the configuration of some, but not all, of the larger Wi-Fi based locations, like their campus networks, were all configured this way. So again, it's about communications. It's about talk to your network team, understand how your network works. It's in their interest and it's in your interest as well.
It's an interesting fact where you said there because we started talking to these network teams and they didn't see the issue and they didn't understand what we were seeing, and they were like, nope, this is something else, nope. And then deep down, after more or less they looking into it, they were like, yeah, but of course this site is used for central switching. And everybody goes like, well, okay. So first of all, what does that mean for the people, for the company that we worked with? Their internal config manager team, they didn't understand the concept of central switching. So when we went through it, then the networking team said, yeah, all traffic goes. So if two clients try to talk, everything goes back in the main data center over the WAN and then back again. And it was like a aha experience for the admins to realize, so why are we trying to implement peer-to-peer here? It will just make things worse. And the networking team said, yeah, why are you trying to do peer-to-peer? And then the config manager guy says, well, because transfer speeds are so slow to this site. And then the networking team would, well, we can turn it off. And all of a sudden, it was like this magic moment where the config manager teams or the system admins were talking the same language with the network engineer, and just magic happened because they were able to communicate. The networking team said, yes, we will sort this out and we'll test these on a few sites and everything will just be happy. So it was pretty amazing to see that you're trying to fight something with the technology, but you're trying to do it in a way that it would just hurt the network even more.
Yeah, and more. Another thing that we're seeing more of as well is large subnets. So a lot of locations that are deploying Wi-Fi everywhere. It's really easy to just create one big subnet. Why go to all of the trouble of segregating all of this traffic? You just create a huge subnet across potentially spanning physical locations. We've seen that before. So it's not uncommon for us to see subnets of 2,000 or more endpoints simultaneously trying to get content. This can cause issues with branch cache, and we could do a whole session on that, but basically the multicast traffic that branch cache generates can impact the airtime of the Wi-Fi network. Even peer cache, just the sheer volume of stuff, because bearing in mind that everything has to go through the access points. Delivery optimization, which is obviously the new content delivery kind of service in Windows 10, has its own issues because it uses ARP in the process of getting content between peers. Then again, really, it's about knowing your network. And if you've got a Wi-Fi network that is using pretty up-to-date modern access points, so using pretty good hardware, and you've got a low number of endpoints per access point, then it's probably going to be fine. But if you've got a slightly older kit, and if you've got 20, 30, or 40 machines per access point, then you're going to be in trouble, and it's going to be the network and it's going to be the user experience, I should say, that actually suffers at the end of the day, because they're going to see a lot of slowness. All of this impacts the stuff that we really want to avoid impacting, which is the user experience, which is the user doing their, their line of business apps and their browsing and their kind of day-to-day jobs. And that's what we absolutely must try and avoid doing. So again, it's about knowing your network. So if you've been seeing issues like this, if you've got slow performance on your Wi-Fi networks, go and talk to your network team. Get to know how it's configured, get to know how large those subnets are, get to know what kind of access points are being used. It's really easy to do, but it can be a quick win.
Yeah, and in this final case, we had a customer that just moved into a large new HQ. They had a couple of thousand machines on a single Wi-Fi subnet. That was the only networking available. Of course, it went into, must be an issue with your product, because at random we see weird things with a large number of broadcasts. And we started asking the correct questions to the networking team, and he went from, well, it's not actually really proper broadcasts, and then we went into, okay, it could be ARP messages going from delivery optimization, and we started using that. Then it went to, no, we'll look into this even more, and basically it proved to be a printer that had a faulty network card that was just flooding the Wi-Fi network with traffic, and it took down a couple of thousand of devices at the same time, and nobody could do anything, all due to a printer hardware physical network card. So just because you think it's something else doesn't mean that it is what it is. And I think that concludes the session.
That
1 minute
is pretty
over.
much it.